Monday, October 29th. I'm Scott.
I'm Rim.
And this is Geeknights. Tonight, we teach you about CPU architecture.
Let's do this.
All right, so I wrote a thing on my blog, which I've been doing more recently, because I said, hey, I got free time at work. You know, I haven't written my blog in like months. I used to do at least like one thing a month at least, you know, so I'm loading it up again. So,
it was also something that we and the crew were debating.
Yeah, well, I wrote it, then I brought it up to confirm that other people were thinking the same thing, and then I posted it. And then I said, you know what? This is sort of dig material here, this thing I wrote. And you know, there's a stigma about submitting your own thing to dig, right?
Well, a stigma among crazy dig people. No one else seems to care.
I sort of bought into the stigma because I felt like, you know, it was sort of like this shameful self-promotion kind of deal, you know? So, but you know what? I said, all right, I'm going to dig it. So I dug it. And then it made the front page eventually. And I was like, oh, well, look at that. And I sort of realized that stigma is completely stupid because think about it, right? Sure, I dug it. What did that do? That brought it to 1. What's it at now? Like over 1,100. So what does it matter if I dug it 1? It's not, I mean, no one else in the world cares if that story gets to the front page besides me. No one has a motive. There's no ads on it. All right. So the fact that it's 1,100 means that my story must have been good enough that I wrote that over 1,100 other people thought that it was good or clicked on it for whatever reason. I don't know what they're thinking.
Well,
mostly it was the headline, I think.
I think we've learned 2 very important things about dig and dig users.
I've learned quite a few important things, which I wrote a blog post about.
Yeah. Well, I think number 1, I just want to get this one out. It seems like the formula to getting dug up is inflammatory headline plus wall of text that many people will not read before commenting.
Well, that's one formula, but I think the number one thing is headline, because you know, once my story got on Dig, it got linked all over the place, you know, at other places that cared about it, right? And I looked at comments on many of those places and on my blog, and no one fucking read it. I mean, there were a few people who read it, and those people were like, they pretty much were like, yes, I agree entirely, and some people said, yes, I agree entirely, here's an additional thing. The only people who said things that were anti obviously didn't read every word that I wrote. And
I like how a lot of them, they'd say something like, oh, well, it's not blah, it's blah, but that's pretty much exactly what Scott said.
Yeah, some people were like, oh, I'll explain it because it's my own writing is going to be my news, take that. Another thing I learned, right, is that you know how you go on Dig and WordPress is always infamous for going down, like, oh, you got dug on your WordPress blog and now it's not working. I got a WordPress blog. It was just fine. Perfectly okay. I think that everyone who has their website go down. All right, and I'm not even doing any caching or anything special. It's just Linux, Apache, MySQL, and PHP 4. It's old and busted, right? This is old and busted Linux we're talking about here. Not even the new hotness. And it was just fine. And just WordPress going, thousands and thousands of people visiting, no problems whatsoever.
So, respect minus for anyone whose blog goes down.
Granted, I didn't have any images on my blog. It's just CSS and text. But even that, I mean, if your site goes down from getting dug, either you're serving up something big time, or you got like the $5 hosting plan, which is, you can't eat. If you get the $5 hosting plan, that's because you don't expect anyone to ever visit your website except you and maybe your friends. Or they just don't know how to set up a web server.
But I think most of those people don't actually set them up. They just buy a WordPress on somewhere.
Or they get a free one at WordPress.com.
Yeah, that's not the best place to host anything real.
No, I mean, that's the place you host something like no one's ever going to look at this, but I want to make it, so I'm going to. Yeah, the headline is all that matters to getting dug up a lot, pretty much. No one will read what you wrote except for a few cool people. And
I do find it interesting how it seems like very few people bother to comment on an actual blog anymore.
No, a lot of people commented on my blog.
But compared to how many people commented on Dig.
Oh, yeah. And plus, a lot of people commented on like osnews.com and other places.
That's what I'm saying. I feel like, because most of the comments I see on actual blogs, especially kind of small blogs, are usually either fanatical people or people who are in the community around blogs or that blog or something. And I don't know. I feel like the only place worth commenting on things anymore is in the sort of meta sites. Like, if I'm going to comment on a story, I'm going to comment on Dig. I would never think to even comment on the blog.
It sort of depends. Like,
unless
I'll comment on the blog because I want the person who wrote it to see it.
Well, that's what I was about to say. I would comment on a blog only as though it were an open letter to the person who wrote the
That's
blog.
what I'm saying. Because I want to talk to that person. If I'm on Dig, I'm sort of talking about the article to the Dig people. It's sort of like who you want to talk to. However, I really think that right now we have a trackback system that's sort of an open standard on the web that's pretty much used between all kinds of sites that, and the way it works is you have a blog, you write a story. If I write a blog story about your blog story and I link to your blog story, most blog software, like WordPress and stuff, will then, like, if I blog about your blog, it'll automatically put a comment on your blog that links back to my blog, right?
I think a lot of the reasons for this are kind of self-serving in order to create, web networks for
But
Google.
It sort of lets you, if there's a bunch of people blogging about the same thing, like there's a news story and 10 people blog on it, you can go to the news story and there'll be links to 10 different blog posts about it. So it's sort of like what you can do is instead of putting a comment on someone else's blog, if you want to write like an essay, you can make that on your own blog, but it's also a comment. And I really think we should have some sort of system where, in addition to that, if someone comments on Dig should post that comment as a comment on the blog. You see, that's perfectly technologically
I don't think it
feasible.
would be that hard to use the API and just scrape comments from Dig. I don't know if they like it.
You could just scrape comments from. Yeah,
I mean, what are the terms of service on the API? I never looked.
I have no idea, but that would be a solution. But I think that the sort of track back solution would be the technologically superior one.
See, it's really hard to say because how many people? I mean, look, it's kind of the 1% rule. How many people read a website? How many people are going to comment on that website? How many people are going to go beyond simply commenting?
Yep.
Like, it's a solution that solves a problem that very few people actually have.
Well, it's one of those things that benefits the bloggers, because, I mean, how cool would it have been, right, if I wrote this blog post, right? Some people comment on the post, some people comment on Dig, some people comment somewhere else. I had to sort of travel around the net looking at refers and things to find out all the people commenting, because, usually on Dig I don't read the comments much, but if it's my story, I want to read all the comments, see what people have to say, And
I guess you could set
some
up.
of it was good and worthwhile, but
and semi-standard blogs, or common WordPress blogs, you could probably set up something where the trackback scraped comments from the other blog posts.
that's not how trackback works.
Well, you could use that to figure out where where someone wrote a story about you, and then have a separate thing that gets triggered that goes there, scrapes the comments, and puts them in your blog.
Yeah, but that wouldn't be exactly what you want. But
no, well,
yeah.
there's also you're
Because you
taking
get-
someone else's content, and what are the licenses?
No, it's not. Whatever. But yeah, the point is, it'd be cool to collect all the comments together somehow, so I don't have to go traveling around to find them.
I think eventually most commenting is going to be either in blogs or in some sort of meta site. Maybe not Dig, but like the next generation of, web, whatever, point, whatever.
Well, a lot of people have tried to make things where basically like comment on any website.
Those were all great back in the day, where you could put a post-it note on some website.
Yeah,
and the only
there's
people who
still a
saw
whole
it,
bunch of those.
Yeah, and the
it's
only people who saw it were people who used that service.
Yeah, it's like you keep the separate window open or a sidebar open or something like that, and when you visit a website, anyone who uses the same sidebar, all these comments show up. So
Actually,
as
my
you're
favorite
browsing
one-
the web, there's these comments going on the left.
My favorite one, you could not only leave comments, but you could also just draw on the webpage. Of course, within about a week, it ended up being nothing but
Penises
on every website ever.
Yeah. But yeah, something like that. The current implementations are not so good, but the idea is definitely sound.
Well,
And
the problem
I would
there-
go for it if it worked out.
No one did it well enough for everyone to use their solutions. Everyone used different ones who cared about that, and no one else cared as a result. I guess if any one thing that did something like that got critical mass, it could be great.
Yep. Because if you just all the comments about everything would be in, one unified place.
Of course, how do you deal with moderation? I mean, Dig's moderation system barely works. Slashdot only works because all the stupid people left.
That's why it's not happening yet.
Well, I guess
One of the reasons.
if we solve the problem of comment moderation and spam prevention, then this sort of thing gets a lot easier.
It does. Okay.
Anyway, so it must be Scott Night because this news affected Scott in a very near and dear way.
Uh-huh.
There is a bug.
It's actually this is sort of an old news. Like it's many weeks old, but it's suddenly coming out.
Well, I didn't
into
know
the
about
open
it. I don't think many people knew about it, and they probably should.
Yeah.
There's a bug in Ubuntu.
It's in Linux in general, I think.
Yeah,
mostly Ubuntu.
I don't have it because I have all that power management stuff turned off.
Well, it's mostly laptops that have this problem because even if you don't have the power management stuff turned off, your desktop computer is on AC power, and thus the power management decides not to enable this
Well,
thing.
yeah, but like even in the BIOS, I disabled all the power management for various reasons.
That has nothing to do with it. Linux ignores that.
Yeah, and I also disabled it in Linux.
Yeah, well, that does matter.
I did both.
Yeah.
And basically, if you're using Ubuntu on a laptop and you're using various ACPI things are going, your computer will just spin up and spin down the hard drive a bunch.
It's not spinning up and spinning down.
Well, it's parking the heads.
It's parking because in a laptop, right, you want to save electricity because you don't want your battery to run out. And you also, the heads, the things that read the hard drive, you don't want them sitting on the hard drive when they don't have to be because if you bump the laptop or drop it, that can damage the drive.
Yeah, now remember, they don't actually sit on the hard drive. They hover.
They fly above it.
Yeah, they're a little wing. But anyway, we did a whole show about that a long time ago.
Right. So the power management thing in your laptop will notice, hey, the computer's idle. No one's really doing anything with me. I'm going to pick up the heads on the hard drive and put them to rest. I'm going to park them. That's what it's called, parking.
But, well, the real problem is just that, all right, your computer can do that. But if the hard drive is spun down or the heads are parked, the bug will often, if you're experiencing it, just immediately tell the hard drive to unpark or spin back up.
Basically, what it does is it tells it to park when it doesn't need to, and it tells it to park too often. So you get a lot of, oh, I'm idle, park. I'm not idle, unpark. I'm idle, park. I'm not idle, park, unpark. You know, it like parks a whole bunch of times unnecessarily, and you know that isn't really so bad. But the problem is that any hard drive is rated for a certain number of parks. So if it parks, say, 10,000 times, it's going to wear out and it's going to be the end.
And the worst thing is the bug, a lot of people, I'm reading all the comments of people looking at their stats and seeing what's going on. The bug will put it into loops where it'll park, unpark, park, unpark constantly for like 10 minutes sometimes.
Yeah.
And the long and short of it is that Ubuntu can destroy your hard drive.
Yeah, it's really not so much a bug as a bad configuration, but yeah, it destroyed my laptop's hard drive.
Yeah, however, it worked out because now Scott's got that fancy solid state drive.
I bought a solid state hard drive, which has no parking. It's all flash. Take that.
And while it will eventually not work anymore because, you know, flash...
It's rated according to the manufacturer, so take that with a lump of salt the size of Mount Rushmore, right? It's rated for, guess how, you know how they rate hard drives for hours of working, right?
Yeah.
All right, how many hours is like a normal hard drive rated for?
God, I don't know. Some stupid amount of time.
Like thousands of hours, you'd say?
More than thousands.
All right, well, this solid state drive is rated for 2 million hours of operation.
Yeah. Now, granted, the real thing that'll make, I mean, it can't wear out from being used. It'll wear out if you're writing to it a lot. And
That's
then
why I
to
turned
it.
off all the logging.
Yep.
And that's going to save me a lot.
I mean, it's not like if you browse the web too much, the cache is going to ruin your drive. It's more like these things do have a finite lifespan, but
yeah,
it's
like
not
if
like
you had 1 bit of flash memory, right? You write a 1 to it, you erase it to a 0, or you can and you write a 1 to it.
Don't you erase to 1 in Flash?
It doesn't matter.
Electrically,
I'm explaining it to
I
you.
know.
I'm not, so it's 1 0 1 0 1 0. You can only do that so many times before it just doesn't work anymore.
Yep. So on a hard
you'll
drive,
only break that 1 bit. You won't break any other bits.
Yep. And I mean, flash drives are supposed to, and there's different ways to do this. They'll write. And then if depending on when you're writing data or overwriting data, sometimes you can rewrite the data and not have to refresh all the bits.
Yeah, the flash drives have the logic in them, so you don't have to worry if Linux or Windows supports it. Modern flash drives are smart enough that they will die at the slowest rate possible with modern mathematics.
But I'm not going to say really more other than if you're running Ubuntu, particularly if you're using a laptop or use a lot of crazy power management for whatever reason, read this, do what it says, see if you've got the problem, and prevent it. Otherwise, your hard drive will die.
There are ways to use HD Parm to make your drive park less or not at all.
What I'm linking to will tell you exactly how to see what's going on, and from there are links to pretty much everything you can do to make it stop happening.
At the present time.
Yeah. I imagine there will be some sort of official fix just to make it go away. But for now, even if you've had the problem and you find out about it, it might be advisable to back up your important data. Because, as we all know, Smart is not going to tell you when your hard drive is going to fail.
Stupid.
Smart is going to tell you basically nothing.
Yes. All right. So I wrote that blog post that got dug up to the front page.
Yes, you did.
Well, you know what that blog post said?
I'll let you run with this.
All right. So you're using your Linux, right? And a lot of people, they say, oh, Linux, it doesn't support this hardware or that hardware. It's like, oh, I couldn't get this to work. Oh, I couldn't get that to work, right? And that's true. There are many pieces of hardware that just don't work in Linux that for Windows, it comes with a driver CD or it just works in Windows or whatever, right?
Like my motherboard, my sound card.
Well, no, that's not what I'm talking. Like, there are many people who have a wireless card. They just can't get to work, right?
But like half the things on my motherboard just don't work in Linux.
No. But there are other things, most things actually in Linux, I would dare to say, right? More so, there's, for everything that doesn't work in Linux, at all, like, there are a bunch of things that do work. I mean, it works on my computer, works on my laptop, it works on the vast majority of PCs out there. It works on my parents' computer.
Yeah, I mean, if you really look at it, all told, in terms of all the consumer hardware still available on the market, Linux supports out of the box a hell of a lot more than Windows.
Yep. The problem is that a lot of the stuff that Linux does support, it only supports mostly or kinda. Or it's like, for example, my sound card, right? In Windows, my sound card has crazy advanced features. Like it can do hardware mixing, surround sound up the wazoo, forward, like back, Dolby Digital, DTS, God knows
what. You can
what.
turn on like enhancing things that are chips on it or firmware things on it.
Oh, there's all sorts of crazy stuff that the sound card built into my motherboard, the piece of shit sound card on my motherboard can do. In Linux, it can pretty much play audio and record audio, and that's it. I mean, you go into the mixer and you see all these options, but they don't do anything.
Or if they do, they don't really like even old sound cards. You go into the ALSA mixer. All right, it says all these gibberish options at the end, and those change those parameters on the card. But because they're not really supported, no one really documented them or used them properly. You can't know what changing those will do, and it'll probably just make everything sound terrible.
Yeah. So it's like things work in Linux enough for a person to use their computer. And most people might not even realize that, they have, features of their they have working hardware that is supported by Linux, but not every feature of the hardware is supported. Now, sometimes the problem is a problem of the driver in the kernel, where it doesn't actually support the feature on the hardware. For example, a Sound Blaster Live, the EAX is unsupported by the driver. It's not going to happen. But in other circumstances, it's supported by the kernel. So the kernel can get this information from your hardware. It knows how to talk to your hardware and get all the stuff going on. But the user space, the software outside of the kernel, either ignores or doesn't want to deal with your particular piece of hardware or the special feature.
Now think about this
dichotomy. You don't have
dichotomy.
any access to it in the user interface.
So all right, it's supported and it technically works, but it doesn't really work.
Mm-hmm. So what I was saying in the blog post is that it doesn't really matter whether it's unsupported by the kernel or unsupported by user space or whatever. The point is that Linux really isn't, if you look at the numbers, right? I mean, a lot of people do complain, my wireless doesn't work, this doesn't work, right? Whatever. If you look at the numbers, there's a whole shit ton of hardware supported by Linux. In fact, Linux supports a lot of hardware that Windows doesn't support, like, PowerPC chips, and you can run
Linux
Alpha.
On an Alpha.
Yeah.
We'll be talking about that.
We're going to be talking about that very soon, this episode. But, Linux runs on a lot of hardware, including a lot of hardware Windows doesn't run on. The problem is a lot of the hardware that Linux runs on, the user of a desktop machine will not actually be able to access all the features of that hardware. Like my scanner, the buttons on the front of my scanner don't do anything. I got 2 buttons on my laptop, they don't do anything.
Or the sound card that came into my motherboard. It'll play audio just fine.
It's recording this podcast right now.
Well, no, I'm using my old Sound Blaster.
Oh, okay.
Because it can't record in Linux. It just doesn't work.
Oh.
ALSA Mixer just can't deal with it. No matter, and when you do, you can get it to record kinda, but it records like shit because there's some setting I gotta change.
Yeah, so it works, but it doesn't work fully. And
now the guy who wrote the kernel module will say, yeah, it works fine, and he's right. His kernel module probably works 100%. That's not the problem, but to most people, I mean, not us, but a normal person who doesn't care.
Because in other operating systems like OS X and Windows, I mean, there is in the software architecture a separation of kernel and user space. But in Linux, it's a really big separation, completely separate.
Plus, in Windows, think about it. Most people buy a thing and they put it in their computer, right? And it comes with a CD. And the CD includes the kernel space, the driver, and the user space, the program, the whatever.
Yep.
And in Linux, that isn't usually the case.
Yeah, it's like the kernel developers keep making things in the kernel, and then the user space people, choose which ones to or not to do. That's why if you use GNOME and stuff, or you see you have access to certain things, and they make user interfaces for some parts and it's not for others. And KDE makes a user interface for every part, and it's crazy complicated, and it's not you.
Yeah.
So it's these two ends of the spectrum, and it's And that was basically what I was saying in the blog post was, hey, we need to concentrate, we still need to concentrate on making hardware work in Linux, but we've mostly got that down, as almost as good as we can.
Yeah, well, my complaint earlier about how half the stuff on my motherboard doesn't work. It works in the newest kernel. I'm just using a slightly old kernel because I'm using a slightly old Ubuntu.
That's the most you can expect. If you buy a brand new motherboard, just on the market, and all the features work in the next kernel, that's about as good as it's ever going to be.
And that's fine.
That's fine. But we really need to concentrate. Maybe we've got Sound Blaster Live. The card is 10 years old and not all of the features work. I mean, sure, it would be nice if Creative decided to give us the specs. Yes,
They're not gonna.
Yes, that would make the world a better place. But I mean, we're reverse engineering stuff left and right. We can't reverse engineer a 10-year-old sound card.
I think the issue is that the people who would write the user space stuff don't care. I mean, look at ALSA. ALSA's a pile of garbage.
I know they replaced OSS, a pile of garbage, with ALSA, and ALSA's still a pile of garbage.
It's slightly less a pile of garbage.
They put ALSA in the kernel. Still a pile of garbage.
And, I mean, Jack doesn't... I mean, people say, oh, Jack. But Jack doesn't do what a lot of people think it does. And it's not going to solve the basic problem of things not working.
Yeah, it's a lot of people commented on my blog post saying, what are you talking about? My sound card does more in Linux than it does in Windows. I can get it to be all low latency for my stuffs. And I'm like, well, that's what you need. But what about the surround sound? It's depending on your particular, thing you want to do, if you want low latency sound... Linux is the business because you can get a craptacular sound card and make it do awesome things.
Yeah, I mean, we're doing that now with Jack. We're recording in super awesome low latency crazy.
Yeah, but then again, in Windows, your craptacular sound card can be a surround sound home theater monster. In Linux, you can't do that.
Also, the fact that the sound card just works in Windows.
Yes. So, it's mostly sound cards and my mouse and stuff like that. But Linux really needs to concentrate on looking at the hardware that works and making it work fully. Make every single feature on the piece of hardware work. And in fact, if you do that, you'll usually turn out better than Windows. Like I just said, the sound cards being low latency in Linux with Jack that don't do that in Windows. The hardware has a feature that Windows doesn't do. So if Linux can make every feature of all the hardware available, then it will be better than Windows across the board instead of just in the areas of stability, security, and performance.
Things of the day. Now, once again, it is Scott night, and I can say that Scott is the one who discovered this, but
I discovered it we were on YouTube, and I was done with dig videos and things, so I just clicked on YouTube randomly, and I saw the thumbnail, which looked like an animation of some sort, so I clicked it. That's how I discovered it.
Much like the zombies in one of these things of the day, we stumbled upon one of the few undiscovered nests of awesome on the internet. And we played it out. We went from this is great, we watched it all, now we're done with it.
All right, so there's a guy, and his username on YouTube is Grickle, Grickle. And his real name is Graham Annable. I hope I pronounced the last name right.
Graham Annable.
His first name's definitely Graham. Anyway,
Annable.
He's a cartoonist from Oregon, and he's also an animator and stuff. And he's made a lot of things. He's got some comics going on, which I'll probably be trying to check out and all kinds of stuff. But he's made a bunch of these animations, and they're on YouTube, and all of them are awesome to one degree or another, and you should just go to his YouTube channel and watch all of them. Now, we're going to use two of them for our things of the day.
I debated, what if we just get people to watch them in the order we did? Because we happened to watch them in an order that created large levels of ruffle.
Yeah, it is true.
I guess, if nothing else, some of the videos are just really funny or interesting or well done on their own. And all the rest of them have this kind of Ren and Stimpy humor to a little degree. And they're all kind of the same. But them all being the same does not detract. It's like it builds up over time like a Family Guy joke.
Yeah, it's like if you the two videos we're gonna use as thing of the day are good on their own, right? But there's these other videos that are all really short, like a minute or less than 2 minutes mostly, and they all follow a common theme. And individually, some of them are good, like the alien one and the Western one.
The Western one, because we watched
I love
that
the
one
Western one.
like last. So I'm like, the thing pops up. And I'm like, I know what's gonna happen. And then something else happened. I'm like, oh. And then the thing I expected happened.
Yep. And if you watch them together, like you just keep watching and watching more and more of them, and they all have the same theme, it gets funnier and funnier.
So, first off, this is by far my favorite one, just because of
It's
the
a
way.
great one.
Just because of the way it ends and how they could have gone a lot of directions with it, but the fact that they immediately end it with, well, obviously.
You should get the T-shirt of this one. This is the only one on his website. He sells merchandise, and he sells a T-shirt for this animation.
I very well may.
And it's your style because it just has the tiny icon in the top left area.
Yep, but I don't even want to ruin it.
You can't ruin it. It's a minute and 40 seconds.
It's called Space Wolf, and it is everything you would hope it to be.
It begins with some astronauts. That's all I'll say.
Oh man.
Okay. The one I'm going to talk about is the first one we watched, which is called The Last Duet on Earth. And I will tell you that this is an animation that's almost 4 minutes long, and it involves zombies.
It's
And it is poignant and humorous and wonderful.
I also, again, we don't want to ruin it, but it is quite the high quality.
Right. So what I recommend you do is watch these two things of the day, and then we'll have a link to them individually, and then we'll have a link to his YouTube channel. Just go to the YouTube channel and pick one that isn't one of these things of the day.
My recommendation, if you see it,
yeah.
there's one about aliens. Watch that one first,
Right.
because it will introduce something.
So watch the alien one. And after you watch it, which is like Transmission Tower or something like that, right?
It's pretty. There's a transmission tower and some guys.
Right. Watch that. Then at the end of a YouTube video, it'll say, here's some other recommended YouTube videos. Just keep clicking on ones you haven't seen until, you start seeing the same ones over and over again. And then go to the YouTube channel and clean up and make sure you've seen all of them.
Pretty much run this out and be done with it, but while you're running it out, do it with a bunch of people. 'Cause
Yeah.
it's great.
Just watch as many of these as you can, and when you figure out what the common theme is and you start seeing more and more of the common theme, it really starts to work its magic on you. And watch out for the Western one. That's one of my favorites.
Because you're going to think, oh, I know what's going to happen here. And you're wrong, but not entirely. Right. So we're going to go. I mean, this is one of those how computers work nights, but we're going to go, unlike previous ones, really broad within a range and kind of shallow, because deeper than where we're going is a place you don't want to be.
Yeah, I mean, it's basically like we're going to talk about CPU architectures. x86, PowerPC, Alpha, ARM.
You might have heard like RISC system, CISC system.
Spark.
Yeah, all those things.
People talk about these things, AMD 64, stuff like IA 64. People talk about these things, and most people just go, oh, it's a different kind of, cell processor.
Different kind of something.
Yeah, it's a different kind
something.
of chip something. You don't really know what that means, really.
Like, there's the Pentium, but then they had MMX.
Yes, to explain the actual differences between them, it would take forever, and it's so complex.
And you don't care.
And you don't care, and you don't need to know. Unless you're writing assembly language programs in assembly language, or maybe in C, you don't need to know this. Or I guess if you're designing chips, you need to know. But that's about it. And it's not useful for the average person who wants to learn how to take advantage of their computer. So we're going to make analogies and metaphors of pretty much everything, so that you will only know as much as you need to know.
And in between all that will be brief explanations of the acronyms and jargon, just so you'll know when someone says RISC system, like, oh, well, that's that thing.
Right. So, you have a car, Rem, right?
I do.
I have a car. Is our car the same car?
No, it's not.
But they do basically the same thing. I mean,
I get where I'm going. Gas pedal, got an engine, exhaust.
Right.
Radio.
So I got an AMD.
Rotten apple in the bag.
In my computer, I got an AMD, right?
Yeah.
And your computer, what you have?
I have a Core 2 Duo.
Right. Completely different, right? They're like, if you look at the physical things, they're nothing like each other.
Yeah, mine's got this really little, totally silent fan on it, and it's this tiny little chip, and it's got an Intel logo.
Right, mine's kind of loud, and it's
Kind of
AMD
slow,
on it.
kind of hot.
Mine's not so hot.
No, but it was cheap.
But they do pretty much the same thing, only yours does it faster and with 2 cores.
I mean, think of this. Installing Windows on Scott's computer versus my computer, it's not like I have to install a different version of Windows.
Yeah, it's the same thing because they both have the same architecture. They 4 wheels and they go. Mine is 4 wheels and it goes. Only Rims has a bigger engine in it, but it doesn't matter. If someone teaches you how to drive one, you can drive the other, and it's the same thing. If you write a program for one, the program will work on the other.
Unless it's a weird different other one. Like, say my car was a Mazda RX-7. It goes like a car, but
I don't think that's
inside...
the best analogy. I would say more if it's like if your car didn't have a steering wheel, if it had levers instead of a steering wheel, and you'd have to completely relearn how to drive.
But I don't know, because the user... Well, I guess to take the metaphor to higher level, because the inside of the car is different, but once you get it going, driving it's the same.
Yeah, the inputs are different. How you control the car, how you talk to the processor and get it to do what you want to do, and how it works internally is different. But the function of it is to digital computing. That's what it does. Is it computes digital things.
Because you might remember we did the show about, like how processors work and how everything else works, and how, you write a program. The program's a language, and that gets translated into like the machine code, and that's what you talk to the processor with.
Yep. I mean, a processor it's a chip. It takes input, does stuff, and then outputs, right? And it's got some registers in there and other business. It's crazy. That's the part we don't want to talk about.
Yeah.
But you generally tell it to do things, and it does them, right? So an x86 CPU has the x86 instruction set. And you can tell it x86 instructions, and it knows how to do them.
Yep, there is a list of commands, and if you tell it those commands and give it inputs, it'll always answer those commands the same way.
Right.
You don't care how it comes to the answer, you just know that it's going to give you the same answer every time.
So I can write a program that says, move the memory in address 1 to address 2, right? And what that'll do is it'll look at the bits in address number 1 and move them to address number 2. I can take that x86 program and put it on a 386, and it'll run it. I can take that same single assembly instruction program, which is a program, by the way, it's just one instruction, though, and give it to RIM's computer, and it'll do the same exact thing, because it's x86. x86 instructions, it works. This is why you don't need to recompile a program if it was written for like a 386, and it'll still work on your computer.
It might not work as well, but that's because it's a whole bunch of other things.
Right. So now when someone talks about something like SSE,
or MMX.
or SSE2 or 3D Now, right? What they're talking about...
3D Now, we hardly knew ye.
What they're talking about are extra instructions. So, or AMD 64 is extra instructions.
Well, let's look at it this way. Say you've got a processor, the RIM proc, and it's all it can do is add binary numbers together.
Yep.
So say I want it to multiply, I have to tell it to add a bunch of times. I want it to divide, I have to tell it to subtract a bunch of times and do a bunch of other things.
Well, you have it actually, if it adds, it can add, subtract, multiply, and divide, because you can add negative numbers a bunch of times.
Well, yeah, that's what I was getting at. But the point is that if I want it to multiply, I have to tell it to add a whole bunch of times. I've got this one simple instruction, add. If I want to subtract, I have to tell it to add a negative number. Now, say I make the RIM proc plus. It supports everything the RIM proc supported.
So the programs written for RIM proc that just add a bunch of times will still work on the RIM proc plus.
It still has the add command, but I added a new command, multiply, and it's special. And if I tell it to multiply, internally, it might do a special chip thing to do the multiplication. It might just translate that to a bunch of adds. It might have a separate adding pipeline optimized for multiplying, but the point is, it's an extra instruction I have added to do a commonly done thing faster, better, easier, simpler.
Yep. So now programs written for RIM proc will work on RIM procs and RIM proc pluses, but programs written for RIM proc plus only will not work on RIM proc, because
I like how
it'll tell
saying,
RIM proc to multiply, and RIM proc will say, "What the fuck?"
We keep saying proc differently. Like
I know,
RIM proc,
right?
Tupac,
who not?
whatever.
Right. So if you compile a program you wrote for x86, it'll work on any x86. If you compile it for 586, it won't work on 3 and 4 86s, but it will be optimized for I mean, if you think about it, if you want something to work on any x86 processor, you can't use any instructions except for the instructions on the 386 or the 286, or actually the 8086, the original.
Realistically, the 386.
Right. Realistically, the 386, because that was the first one that worked in the modern fashion, but that's a separate story. So it could go a lot faster. I mean, you could use all the special instructions that the Intel Core 2 Duo has that the 386 does not.
Yeah, because they don't add those instructions for the benefit of programmers to make it easier to write assembly. They add them because they've made a thing usually that'll do that thing faster than if you did it manually.
Yes, the compiler knows the thing that converts your, normal programming language into assembler, which most people don't deal with assembler anymore, at least on PCs. It converts from C to assembler. If it knows that you're on an AMD 64 and you wrote a program in C, it knows about these extra instructions and it will use them if it has to. It knows. It's smart. So you tell it which processor you want to compile for, and it will compile for that processor. Hell, you could even be on an x86 and say, hey, compiler, compile this code for PowerPC so I can run on my Mac.
But then you can't run it on your computer that you just compiled it on.
You have to copy it over to the Mac and then run it.
Now, see, this is why when people use Gentoo or Linux from scratch, they talk about, I'm going to optimize my kernel. I'm going to optimize everything to run on my PC. They use, a March instruction or something to basically compile for as much as they can. They'll look at their processor and tell the compiler to use all the stuff that processor supports as much as possible. But now that code won't run on a lesser processor or a different processor.
Yeah, it just won't happen.
If I compile something for a 686 and then I give it to you with your 586, it won't work.
And that's the theory of a source code based distribution of Linux, is that we're not going to compile the code and then give it to you. Like in Ubuntu. Ubuntu compiles the code and gives you the results of the compilation. You download the binaries. You don't compile the code yourself most of the time. You download something that's already been compiled by someone else, which means if you had the source code and compiled it yourself, you could probably get it to be better and use your computer better, but it would take forever. Because compiling takes a long time.
Yep, it takes less forever now with fast processors, but still.
Still, I mean, it takes 2 days to install Gentoo Linux. It takes 20 minutes to install Ubuntu Linux.
Yep.
Microsoft Windows, they give you everything already compiled. You're not compiling source code to Windows, or else the world would be a different place.
Plus, it's just dealing with installing everything from source takes a little bit more knowledge, and you got to know.
It's a pain in the ass.
Yes, God, half the time of installing Gentoo is just learning all that crap the first time.
But then again, this is why Gentoo is always one of the first distributions that you can use to, run it on an Xbox or run it.
That's also why, until recently, we were able to do Geeknights fully on an old busted 800 megahertz processor.
Yep.
Because I used a compiled to fuck all Gentoo.
Yep. All right, so you might be saying, okay, I know that, a CPU architecture, different CPU architectures use different instructions, and ones that, they might have all the instructions of an old one, but some new instructions. So things for the new one don't work on the old, but things for the old work on the new, all right? But what are actually some of the differences between CPU architectures? What makes it, why not just have one that's the best one?
Well, we're kind of, in many cases, converging on that.
Kind of. Well, back in the day when they were thinking about it, right, there were these two philosophies of how we're going to make a CPU architecture. One philosophy was RISC, Reduced Instruction Set.
You might be aware
CPU.
of this term from the movie Hackers, where someone said something along the lines of, man, I got a sweet RISC system.
Yeah, I think C stands for CPU, or computing. Reduced Instruction Set Computing?
I don't know.
I forget what the C is. It doesn't matter. It's Reduced Instruction Set.
The idea was that if you have a language for the processor itself that's very simple, and you use, and it's mostly in terms of how the processor handles things internally too. Internally,
pipelining and such.
Internally, it does very simple things very quickly. And if you want to do complex things, the idea was that you can make those simple things so refined and so fast that as a result, complex things are always broken down into a bunch of simple problems that the processor can solve really, really quickly.
Right. So the idea with a RISC, Reduced Instruction Set Computer, apparently according to Wikipedia, right, is that I want to multiply. Well, I'm not going to have a multiply instruction. I'm just going to have the add instruction, and I'm going to make this CPU in such a way that it can add a whole shit ton of times really fast.
Now, you might have a multiply in whatever you're writing with, but the compiler turns that into a bunch of adds before it gets to the processor.
Yep, but the way the CPU works internally, it can add so fast that, it's better than having a multiply instruction. You just go add, right? Now, the other philosophy was a CISC, C-I-S-C, Complex Instruction Set Computer. The idea behind this, as you can guess, was to have a whole shit ton of instructions. That way, you would, whatever you wanted to do, there'd be an instruction that did it. And you would just be like, use this instruction. And it would just do it, that one, And, it might be slower because some of these instructions are pretty complex, but you could do a lot of things with very few instructions. So it's a lot less instructions and do a lot more. And there are benefits to both of these. And, well, in the end, we sort of landed somewhere in the middle. I mean, computers that you're using right now are not really RISC or CISC so much. They have a lot of instructions, but they use a lot of the principles of, RISC design, like pipelining and such, to go a lot faster. And yeah, these were the philosophies that started all, the reasons why we had all these different CPU architectures showing up is because, people were, they were like, we're making something that you give it instructions, it does stuff, and then there's output, right? There's so many different ways to do it. Which way is the best? Let's try all these different ways. And they've tried all these different ways, and we've actually found in the end that some ways are better depending on what you're doing. I mean, people who have like these giant mainframe farms, where they're doing supercomputing stuff, right? They need a different CPU architecture than you do to play, your Team Fortress 2.
Yeah.
They're doing a lot of similar math over and over and over and over and over again. Whereas you're doing all sorts of random stuff all over the place all the time. Who knows? So if you were using, say, a supercomputer, I guess it would be fast just on, the point that it's a crazy supercomputer. But it wouldn't be heavily optimized for the kind of work that you do.
I'm sure we'll get yelled at about minor details from some of our friends who know a lot more about this than we do.
I'm trying to just talk about this for normal people,
yeah.
All right? I'm not gonna get into what a register is, and this you get this architecture has one program counter register, and the other one has 3 double size registers, and it's like
also
I'm not going into that.
I just remember way back in the day, I wanted Windows NT because I thought it was better. Before I realized that Windows NT basically stood for Windows. Nice try, but you could get Windows NT for Alpha back then. And I thought, Alpha? What's Alpha? So I looked it up, and all I knew was Alpha processors had higher megahertzes than other processors. They were like 400 or 500 megahertz, and I thought, wow, awesome sauce. And I always wondered why no one used Alpha and why it was so expensive. And now, Alpha's gone because it doesn't matter.
Well, there's still people who use Alpha.
Didn't Alpha get bought out or something?
Digital Equipment Corporation. I'm not sure who owns it now, but Linux, there was big things in Linux on Alpha in the early days.
Oh, here we go. The Alpha series was sold, along with most parts of the parent company, to Compaq in 1998. Compaq, an Intel customer, phased out Alpha in favor of IA64 Itanium architecture and sold all of Alpha's intellectual property to Intel in 2001, killing the product. There you go.
But yeah, Alpha was a big deal for a long time.
HP now owns it and promised to continue selling Alpha-based systems to the existing customer base until last year.
Because you see, there's a lot
they extended sales until
whatever, no one cares.
Until later last year.
No one cares.
According to Wikipedia.
The point is that there are people out there, mostly businesses, right, where they have an Alpha system that's, say, been doing their business for, 30 years, some long period of time. And, they don't want it. They could either rewrite all that software for some, an Intel machine, or they can just get a new Alpha machine when the old one breaks and keep running the old software, because they don't have the source codes of that software. It's not like they can recompile it for some different architecture.
Even if they had the source code, they don't know how it works.
Yeah, it's like they need an Alpha processor to run their software. So
granted, the real solution would be to hire someone to look at what the business process is and write a new program.
I know that,
but yeah.
Regardless.
Yep, and x86, you might have heard way back that, Apple is moving to the Intel business. That's basically Apple dropped PowerPC and uses x86 now.
And that's why old Apple programs need to run in some sort of, emulating mode. On
and I saw that it looks like Leopard dropped support from
Leopard
that.
dropped it. They screwed it.
Now, see, that's one thing that part of the reason we use x86 today, there's a lot of reasons, but it's simply that backward compatibility has always been considered like the most important thing because they don't want to piss off the people who just use computers and don't know better.
Yeah, I mean, if you have a program that runs in your computer, right? Let's say the whole world came up with a brand new CPU architecture. It's totally brand new. It's optimized for everything. It's amazing.
It's better in every way.
It's better in every way. All right, now everyone, because not everyone's using Open Linux, would just run on it because we just recompile Linux for it, right? Make a new module for Linux and it would work. The same way they did for Alpha back in the day. I mean, Linux runs on all sorts of different CPU architectures. All you do is when you're compiling it, you pick which one you want to use.
Or if you're using like Ubuntu, you download the one you want.
Right. You have to download a different, Ubuntu version for the different, architecture you're using. But Windows, Microsoft had to re-release Windows, and everyone who writes a Windows application that isn't open source would have to re-release the application. And a lot of applications out there aren't going to get re-released.
Yeah, you think Valve's gonna...
only ones that people are maintaining are going to be re-released. So it would just basically be like, okay, we're going to say that pretty much all the software ever isn't going to work anymore. You have to redo it all.
What Apple did back in the day, not back in the day, but when they first switched to Intel, and what the future is showing us more and more, that with VMware, virtualization and emulation more and more, I don't think it's going to be that long. Like in the coming decade, if better architectures are around, people and emulation gets better, I could see general shifts in the future to better architectures with emulation support for old stuff.
There could be indeed. I
mean, it's not happening now on any large scale, but it's happening in server farms already, where like a company has 1 million crap old programs on servers everywhere. And they buy one like supercomputer and they virtualize all the operating systems, whatever architectures, and then they run all those old crap things on one fancy computer that they can maintain.
That's a good way of getting rid of a bunch of shitty computers.
That's a great way of getting rid of a bunch of shitty computers and saving a ton of money because old computers use a lot of power.
Yep. But yeah, in general, there's other differences between CPU architectures. Like here's an example of how they're different. Ready? Some CPUs are big endian and some are little endian.
You really don't want to know. You don't care what that means.
It's pretty simple what it is, right?
Well, yeah, but thinking about the ramifications of it.
No, I'm not going to talk about the ramifications. I'm just trying to show you how there's different designs and why, we didn't just pick one and go with it forever, right? So, you know a binary number, right? Let's say I want to have the number 2 and binary. Well, that's 1 0, all right? Well, what if I put, is it 1 0 or is it 0 1? Am I writing the numbers from left to right or right to left?
I mean, you might say that's a given, but yeah, that's a given if you're writing in English. Your computer doesn't think in English.
Yeah, your computer doesn't think in English. It's a bunch of wires going in a bunch of pins, So it's like, is the leftmost pin is the first one, or is the rightmost pin the first one? You don't know. How is it? So some CPU architectures are big endian, and some are little endian, and it's just a difference, And there are reasons to do one and reasons to do the other, but that's not important right now. The point is that CPUs make those kinds of decisions that matter. If I write a program and I compile it for little endian and I run it on a big endian chip, it's going to be all backwards. All the little numbers are going to be big and the big numbers are going to be little.
And it's not going to work.
It's not going to work the way I thought it would, at least. So this is, why we have different CPU architectures and why programs only work on some and not on the other, and why people, design different things to try to get different things that work different ways, optimized for different kinds of tasks and such. You have all these different cars. You have a sports car, you have a minivan, you have an SUV, you have a tractor trailer. They're all cars, but they all have different design considerations. And, you can get an engine that might work in 20 different cars, but it might not work in a tractor trailer. Yeah, I'm running out of analogies here.
Pretty much, in the end, everything you're going to deal with or care about is x86.
Oh, you want to talk about the travesty of x86 and then end it?
The travesty of x86, you say?
Yes. Well, back in the day, they made the 8086, which is the original x86 processor. And then eventually got to the 386, which is the first one that really mattered. And then the 486 and the 586. And now everything we use today is 686. And then AMD 64s have AMD 64 stuff added on. And there's MMX and SSD and SSD. Right. But it's basically 386 was the first x86 that's real, and Ubuntu will still run at a 386. Well, maybe not Ubuntu, but Linux will run at a 386 still, totally fine.
Now, some people argue that why do we bother? No one has a 486 anymore.
Well, the thing is that back when the 486 came out, they still kept going with it had some stuff the 486 didn't have, and they tacked some stuff on, but they a lot of people still had 386 software, so they kept it going. The 586, and then people still had stuff, so they kept it going. And they just never wanted to screw the most recent generation. And then by proxy, they didn't screw the previous generation. And if you actually look at the way the x86 CPU architecture is designed, it looks a lot like Windows, where it's not some cleanly designed system from the ground up. It was, and then they just kept tacking shit on in order to keep pace with the modern world.
It's much like a post in the average forum with a whole bunch of commas and semicolons and going nowhere.
Yeah, it's basically a big mess. They just kept tacking more and more stuff onto it, like this hideous monster. It's not a very clean and well-designed architecture. However, it works. It still works. And we've learned, because dealing with it over the years so much, that we can design x86 CPUs to be pretty damn efficient. I mean, Core 2 Duo, it's fucking fast. You could use that technology to make a CPU that's a lot faster if it was a different architecture, but we don't really need to, and we want to run all our x86 programs, and no one would, no home user is going to buy a non-x86 CPU nowadays.
Yeah.
So that's just how it is, and it's probably going to be that way for a long time. And, while it does hold us back to some extent, it doesn't really hold us back that much. But it is, if you ever program in assembly language, that's the time when you're going to be pissed off.
Luckily, most of you never will.
Never will, and thus you won't need to be pissed off. Lucky you. I guess if more people had to write in assembler, we would have moved to a better architecture.
If more people had...
people would have gone nuts trying to write
I submit that if more people in the world had to write in assembler, we have moved into a much different society that I probably would like greatly.
But yeah, I mean, it's like... basically, if writing x86 assembly language is like a nightmare, but writing x86... writing like ARM or PPC assembly language... It's not great, but it's a breath of fresh air compared to writing x86 assembly language.
This has been Geeknights with Rim and Scott. Special thanks to DJ Pretzel for the opening music.
Be sure to visit our website at www.frontrowcrew.com, where you'll find show notes, links, our awesome forum, a link to our Frapper map, and links to all the RSS feeds.
We say feeds plural because Geeknights airs 4 nights a week, covering 4 different brands of geekery. Mondays are science and technology. Tuesdays, we have video games, board games, and RPGs. Wednesdays are anime, manga, comic nights. And Thursdays are the catch-alls for various rants and tomfoolery.
You can send us feedback by email to geeknights@frontrowcrew.com. Or you can send audio feedback via audio. Just click the link that says Send Me an Audio on the right side of our website.
If you like what you hear, you can catch the last 100 episodes in iTunes or in your favorite podcatcher. For the complete archives, visit the website, which has everything.
Geeknights is distributed under a Creative Commons Attribution Non-Commercial Share-alike 2.5 license. This means you can do whatever you want with it as long as you give us credit, don't make money, and share it in kind. Geeknights is recorded live with no studio and no audience. But unlike those other late shows, it's actually recorded at night.